Hi students, welcome back to Abhyaas IIT Prep. In this video, we're going to talk about trigonometry. So previous year questions on trigonometry. Trigonometry, that is ratios up to transformations and equations and our inverse. Okay, so let's start with the question. The first question is, let the set of all a belongs to are such that the equation cos 2x plus a sin x equals to 2a minus 7 has a solution p comma q and r equal to then pqr. So we have to find pqr, and pq values comes from this equation, so we have to solve the equation. So let's do this. Given cos 2x plus a sin x equals to 2a minus 7. So cos 2x can be written as 1 minus 2 sin square x, because we have sin x here. This will be a sine equation. So a sin x minus 2a plus 7 equal to 0. That implies this will be 8. I am taking minus away, so that will be 2 sin square x minus a sin x plus 2a minus 8 equal to 0. Okay. So yeah, if we take 2 sin square x minus 8 at 1 place and taking a common here, yeah, sin x minus 2 equal to 0. Ultimately we have to find a value, so that's why we are taking sines other side. Now if we take 2 common, that will be sin square x minus 4 minus a sin x minus 2 equal to 0. So this is a square minus b square formula, right? So we will get sin x minus 2 and sin x plus 2. If we take sin x minus 2 common from both sides, sin x minus 2, we will have 2 sin x plus 2 sin x plus 2 minus a equal to 0. Okay, so we will get either sin x minus 2 equal to 0 means sin x equals to 2. Sin x minus 2 equal to 0 means sin x equals to 2, which is not possible. Yeah, we know that. And we also have 2 sin x plus 4, 2 sin x plus 4 minus a equal to 0. 2 sin x plus 4 minus a equal to 0. So 2 sin x plus 4 equal to a. Now sin x values varies from minus 1 to 1, right? So minus 2 plus 4 equals to a and 2 plus 4 equals to a. Sin varies from minus 1 to 1. So we will get a equal to 2 and a equal to 6. This will be our values p comma q. Given closed interval p comma q, so that will be 2 comma 6. Okay. Now r value, we have to find r value. So we have to solve this equation. R is equals to tan 9 minus tan 27, tan 9 minus tan 27 minus 1 by cot 63. Cot 63 is tan 63, right? Then plus tan 81. Yeah. So tan 81 and tan 9 are complementary. We can write tan 9 plus cot 9. So this is same as cot 9. And tan 27 minus cot 27 we can write tan 63 as cot 27. Now we have tan a cot a minus if we take minus common, we'll get tan a plus cot a again. So let's solve tan a plus cot a. Tan a plus cot a equals to sin by cos plus cos by sin. That implies sin square plus cos square by sin cos. That is 1 by sin into cos. So we will get 1 by sin 9 cos 9 minus 1 by sin 27 cos 27. Okay. Sin 9 cos 9, it's like sin 2 theta. So that will be 2 by, like, sin 2 theta is 2 sin theta cos theta. So equals to cos theta sin theta, right? So we will get sine 18 here and minus 2 by sine 54 here. Okay. So we need sine 18 value and sine 54 value. I hope you remember. I'll be writing that here. So we got 2 by sine 18 and 2 by sine 54. 2 by sine 18. Sine 18 is root 5 minus 1 by 4. Root 5 minus 1 by 4 minus 2 by root 5 plus 1 by 4. That equals to 8 by root 5 minus 1 and 8 by root 5 plus 1. Taking 8 common outside, 1 by, so LCM we will get 5 minus 1 and in numerator we will get root 5 plus 1 minus root 5 minus of minus 1, so plus 1 again. So that is root 5 gets cancelled. 8 into 2 by 4, 2 times we will get 4. So the R value is 4. R value is 4. P value is 2. Okay. P value is 2 and Q value is 6. We need to find PQR. PQR equals to 2 into 6 into 4. 6 4 24. 48. So 48 is our final answer. Okay guys. Let's move to the next question. Considering only the principal values of inverse trigonometric functions, the number of positive real values of x satisfying tan inverse x plus tan inverse 2x equal to pi by 4. So I hope you will read the question from later onwards. So given this equation, we have to satisfy this equation and we have to get positive real values of x, principal value. So let's solve the equation. Tan inverse x plus tan inverse 2x equals to pi by 4. Yeah, we have a formula for tan inverse x plus tan inverse y, which is tan inverse x plus y by 1 minus xy. But we also have another formula, that is pi plus tan inverse x. Pi plus tan inverse x plus y by 1 minus xy. Both have different conditions for x comma y. For x comma y we have different conditions. So we either get this formula or this formula. Generally we use this formula, but since we don't know which formula would be applicable, I'm not going to go there. Let's try solving normally. So tan inverse x equals to pi by 4 minus tan inverse 2x. Yeah, x equals to, if we take tan inverse that side, it will be tan pi by 4 minus tan inverse 2x. This is in the form of tan pi by 4 minus theta, which is 1 minus tan theta, that is 2x, then 1 plus tan theta, that is 2x. Tan of tan inverse 2x is 2x. So we get x equals to 1 minus 2x by 1 plus 2x. Now multiplying and solving, we get x plus 2x square equals to 1 minus 2x. That implies 2x square plus 3x minus 1 equal to 0. Now we don't have factors for this, so go with the D formula, that is x equals to minus b plus or minus root b square minus 4ac by 2a. So 9, 4 2 8 minus, so plus 8 by 2a, that is 4. So that is minus 3 plus or minus root 17 by 4. Okay. Here root 17 is greater than 3. Root 16 is 4, right? So this will be 4 point something. So x is, we are having one positive value, positive minus negative by value. So one positive value and one total negative value. We only wanted to consider the positive real values of x. So we are having only 1. So option 2. Is it okay, guys? Okay. Then to the next question. If alpha minus pi by 2 to alpha minus pi by 2 less than alpha less than pi by 2 is the solution of 4 cos theta plus 5 sin theta equal to 1, then the value of tan alpha is. Again, we have to solve this, but given this has the solution alpha, so we will get 4 cos alpha plus 5 sin alpha equal to 1. This is a solution. We need tan alpha, so divide both sides with cos alpha. We will get 4 plus 5 tan alpha equals to 1 by cos alpha is secant alpha. We have identity for tan and secant, so we will square on both sides. We will get 16 plus 25 tan square alpha plus 40 tan alpha equals to secant square alpha. So from identity we can write secant square alpha as 1 plus tan square alpha. So 16 plus 25 tan square alpha plus 40 tan alpha is equals to 1 plus tan square alpha. Okay. Now we are having 24 tan square alpha plus 40 tan alpha plus 15 equal to 0. No cancellations, so we have to solve. So tan alpha will be minus b plus or minus root b square. 40 into 40 I am writing minus 4ac. So 4 into 24 into 15 by 2a, that is 2 into 24. Okay. We can write 24 as 6 into 4 and 40 as 4 into 10, 4 into 10. So we are having 2 4s common. So 1 4 will come outside. I hope you understand what I meant. In root, we are having 2 4s here and there with a minus. So we are taking common. Since it is root 4 square, we are having 4 only. Root 100 minus 15 6 are 90 by 2 into 24. And now we can cancel 2 times, 20 times, again 2 12 times, 10 times, that equal to minus 10 plus or minus root 10 by 12. 10, no, not this. So this answer. Okay guys, root 10 minus 10 by 12. Simple questions only. Trigonometry is not that hard when you understand the formula and when you can implement what is given. It is easy only. So learn formulas and it will be helpful. Given. Let x equal to m by n. M and r co-prime natural numbers be a solution of the equation. So again we have an equation, we have to solve it. We will get x value which will come like m by n, and let alpha beta be the roots of the equation. So after getting m n, we will substitute here. When we will solve this equation, we will get roots alpha beta. Then the point alpha beta lies on the straight line. Okay. Let's start with the equation, that is cos 2 sin inverse x equals to 1 by 9. Okay. Let sin inverse x equals to theta. We will get cos 2 theta equal to 1 by 9. Cos 2 theta can be written as 2 cos square theta minus 1 or 1 minus 2 sin square theta. Since we have sin inverse x equal to theta, sin theta will be x, right? So I am taking this formula, equal to 1 by 9. So that implies 1 minus 2x square equals to 1 by 9. 1 minus 1 by 9 equals to 2x square. 8 by 9 equals to 2x square. 4 by 9 equals to x square. 4 by 9. So x equals to plus or minus 2 by 3. Okay, we got x value which is in the form of m by n, where m is equals to 2 and n equals to 3. Now we have to substitute it here. So 2x square minus 3x minus 2 plus 3 minus 2 plus 3 equal to 0. So 2x square minus 3x plus 1 equal to 0. Now again we have to solve. I think we have factors here. Minus 2x minus 1 plus 1 equal to 0. So if we take 2x common, we'll get x minus 1, and sorry, this is x minus 1 common, we'll get x minus 1. So x can be 1, x minus 1 into 2x minus 1 equal to 0. So x can be either 1 or x equals to 1 by 2. Now, given alpha is greater than beta, alpha is greater than beta, so 1 greater than 1 by 2, alpha value 1, beta value 1 by 2. The point, now we got the point 1 comma 1 by 2, we have to check on where this point lies, on which line this point lies. Okay, so checking with the first option, 3 plus 1 equal to 4, not equal to 2, so this is wrong. 5 minus 4, 1 not equal to minus 9. 3 minus 1 equal to 2, this is minus 2, so option 4 right. Let's check. 5 plus 4, 9. Okay guys, so let's go to the next question. The sum of solutions x belongs to R of the equation 3 cos 2x plus 3 cos cube 2x by cos power 6x minus sin power 6x equal to x cube minus x square plus 6. So yeah, we have to solve this equation. So that we get the x values, and then we can submit the solutions to get the final answer. Okay, good. So even though the equation looks big, it is not. So let's solve that. Cos power 6x minus sin power 6x equals to x cube minus x square plus 6. We have cos 2x common in the numerator. That gives us cos square 2x by, let's treat it as a cube minus b cube, where a is cos square and b is sin square x, so that we can get the identity. So a cube minus b cube formula can be written as a minus b into a square plus b square plus ab, right? That will be cos square x minus sin square x into cos power 4x plus sin power 4x plus sin square x into cos square x. This will be cos 2x, so cos 2x get cancelled. We taken away one value, so we have to take the remaining thing also. That will be 3 cos square 2x by, this is again in the form of a square plus b square, that can be written as a plus b whole square minus 2ab, 2 sin square x cos square x plus sin square x cos square x. Okay, for here a plus b whole square minus 2ab. So now we got 3 plus cos square 2x by 1 minus sin square x cos square x. I can write it as sin 2x by 2 whole square. So now we have 3 plus cos square 2x by 4 minus sin square 2x by 4. That will give us 4 into 3 plus cos square x cos square 2x. I can write sin square 2x as 1 minus cos square 2x. So 4 minus 1 minus cos square 2x. This will be 3 and minus of minus will be plus cos square 2x. These things get cancelled and we get 4. So the whole part became 4. So now we are left with x cube minus x square plus 6 equals to 4. That implies x cube minus x square plus 2 equal to 0. So we have to find roots for x. If we put values directly, like whenever we get quadratic equations or cubic equations, we usually get 0, 1, 2, minus 1, minus 2. So let's check with that. 0 can't happen, 1 minus 1 can't happen, minus 1 plus 2. So x equals to minus 1 will be a root. X equals to minus 1 will be a root. So x plus 1 will be a factor. So dividing this x cube minus x square plus 2 with x plus 1. So we will take x square here. So that will be x cube plus x square. So minus 2x square plus 2. To remove 2x minus 2x. So minus 2x square minus 2x. We are left with 2x plus 2. To remove 2x plus 2, we have to take 2. So 2x plus 2, 0. This is what we get. So everything is equal to 0. So this equation can be written as x plus 1 into x square minus 2x plus 2 equal to 0. We divided the equation with the factor, we get the remainder. So now x can be minus 1 or x square minus 2x plus 2 equal to 0. So x equals to minus b plus or minus root b square minus 4ac. Okay. So here we are getting d less than 0, the determinant less than 0, 4 minus 8. Root 4 minus 8 is root minus 4. So we can leave it because he said x belongs to R. So x equal to minus 1. So we got only one value. The summation of x will be minus 1. So the answer is option 3, minus 1. Okay. Nice. So let's get to the other question. If 2 sine cube x plus sine 2x cos x has exactly 3 solutions. So let's solve the given equation, that is 2 sine cube x plus sine 2x cos x plus 4 sine x minus 4 equal to 0. Okay. Sine 2x can be written as 2 sine x cos x, 2 sine cube x, 2 sine x cos x into cos x cos square x. Okay, again cos square can be written as 1 minus sine square. So multiplying we will get 2 sine cube x plus 2 sine x minus 2 sine cube x plus 4 sine x minus 4 equal to 0. Here 2 sine cube x get cancelled. So 6 sine x minus 4 equal to 0. Sine x will be 2 by 3. So 4 by 6 that equal to 2 by 3. Right? So this is less than 1. Sin x, the value we got is less than 1. So it exists because sin x exists from minus 1 to 1. Sin x equals to 2 by 3, right? Now we have to find 3 exact solutions. So I will draw a graph so that you can understand. Sine starts from 0 and at pi by 2 we will get 1. So we have to draw a smooth curve. So it varies like that. Now 2 by 3 will be less than 1. So let's say at this point it is 2 by 3. We'll get another 2 by 3 here, and then again we get 2 by 3 here. This is pi by 2, so this will be pi, and here will be 2 pi. After one cycle we will get another pi by 2, so that will be 5 pi by 2. Okay, so from 0 comma 5 by 2 we are having 3 exact solutions, so the n value is 5. Now substituting it here, we will get x square plus 5x plus 5 minus 3 2 equal to 0. X equals to minus b plus or minus root b square minus 4ac by 2a. We are having minus 5 plus or minus root 17 by 2, 17 or 18, yeah, 17. Where does this lies? Okay, this is 4 point something, right? Greater than 16, so 4 point, let's say 4.1. So minus plus or minus 5 plus or minus 4.1 by 2. So 5 is dominating, so we'll get one negative value, and the other also one negative value. So we're having 2 negative values which will be possible here. Okay, yeah, so that will be our answer. Let's go to the next question. This is also a simple question. We have to solve the equation, we will get the answer, that's it. But sine alpha plus beta is given, sine alpha minus beta is given. We have to find tan alpha and tan beta. So we'll simply open this given equation, that is sine a plus b is sine a cos b plus cos a sine b. We are multiplying it with 3, so I'll write it in the next step. Is equals to 2 sine a minus b, sine a cos b minus cos a sine b. Okay, so sine alpha plus beta we are having both sides. So sine alpha cos beta, 3 sine alpha cos beta minus 2 sine alpha cos beta equals 2, and minus 2 plus 3, that will be minus 5 cos alpha sine beta. See, if we take cos alpha this side, it will be tan alpha equals to minus 5 tan beta. Simple question, we are done. K value is equals to minus 5. Okay, so let's go to the next question. If alpha beta gamma not equal to 0, if sine inverse alpha, okay, yeah. Given angle value is equal to pi. So this is a triangle, right? Let's say sine inverse alpha equal to A and sine inverse beta equal to B, sine inverse gamma equal to C. So given A plus B plus C equals to pi. Now sine A will be alpha, sine B will be beta, and sine gamma, sine C will be gamma. We know sine A formula is A by 2R. So we have alpha equal to A by 2R, beta equal to B by 2R, gamma equal to C by 2R. Okay, now we have to multiply this and we have to find gamma. So let's take that equation, alpha plus beta plus gamma into alpha minus gamma plus beta equals to 3 alpha beta. Okay, rewriting this as alpha plus beta minus gamma. Now it is in the form of A plus B into A minus B, A plus B into A minus B. We'll get A square minus B square. So alpha plus beta whole square minus gamma square equals to 3 alpha beta. Now this is alpha square plus beta square plus 2 alpha beta is equal to 3 alpha beta. Then again alpha beta, so we'll get alpha beta so alpha square plus beta square minus gamma square by alpha beta equal to 1. This is what we got. If you remember these sine values, cosine values, I think sine angles, cosine angles, yeah. So sine A is A by 2R. Similarly, cos A is B square plus C square minus A square by 2BC. Okay. Now, if I substitute alpha with A by 2R, beta with B by 2R, and gamma with C by 2R, and we have to have 2 here, but it is not there, so let's take that. Okay. So this can be written in cosine formula, that is cos C. Cos C says that A square plus B square minus C square by 2AB. A by 2R, so let me write that, A by 2R whole square plus B by 2R whole square minus C by 2R whole square by 2 into A by 2R into B by 2R. So 2R square denominator, here also 2R square denominator gets cancelled. We are remained with A square plus B square minus C square by 2AB, which is cos C, and the value is 1 by 2. When will be cos C 1 by 2? Cos 60 degrees. So, okay, C value is 60 degrees. C value is 60 degrees. So gamma will be sine 60, that equal to root 3 by 2. Okay. So root 3 by 2. That is our answer. Let's go to the next question. We are given inverse trigonometry. Okay, this is nice. So given A is equals to sine inverse sine phi. A is equal to sine inverse sine phi. We normally cancel sine inverse sine, but sine inverse should follow, should fall into minus pi by 2 to pi by 2. Pi is 3.14, so we'll get minus 1.57 comma 1.57. So sine inverse value should exist in between minus 1.57 comma 1.57, but we are exceeding it by with 5. So we have to change the value so that it falls under these values. Yeah, I actually made one formula using the graph. So let y is equals to minus x plus or minus n pi. No, I think y is equals to n pi plus or minus x. Yeah. So here x value is the value that is given. So plus 5 and n pi minus 5. Where n are integers, n belongs to integers, both positive and negative. Okay. Now think, we have already exceeded 5. Like we have already exceeded this value and are at 5. So if we are taking n pi plus 5 and we are giving positive values, we will be exceeding more. So we have to give minus values here to come back here. So let's take minus pi minus 1, that will be minus pi plus 5. So minus 3.14 plus 5, that will be 1.686. Okay, not possible. So let's take minus 2. Now minus 6.28 plus 5 will get minus 1.28. This comes in between these values. Okay, so we can take y is equals to minus 2 pi plus 5. Let's check here also. This we are subtracting here, so let's take positive values. So pi minus 5 will be plus 1.86, so it is not possible. And 2 pi minus 5, it will be plus 1.28. This comes under this. But if you think, we were given sine, right? So sine 2 pi minus 5, which is minus sine 5. This falls under fourth quadrant. So sine 2 pi minus theta is minus sine theta. And we were given only sine 5, not minus sine 5. So we are not going to take this value. So we are only considering this value, that is minus 2 pi plus 5. Try to understand this. We are using this formula and trying to find A and B. So this will be sine inverse sine 5 minus 2 pi plus 5, 5 minus 2 pi, that equals to A is equals to 5 minus 2 pi. Got it? Similarly, I'm gonna do the B value. So B is equals to, given cos inverse cos 5. So again using this formula, n pi plus 5 comma n pi minus 5. Where does cos value lies? Cos inverse value will be from 0 to pi, right? That is 0 comma 3.14. It should be under 0 comma 3.14. So let's take, again, if you are taking positive values, we are going to exceed this. So we'll just take the negative values. So minus pi plus 5, minus pi plus 5, we did it, 1.86, no, see, yeah, I think so, 1.86. This falls under 0 comma 3.14, but we have to check. Cos minus pi plus 5 is same as cos pi minus 5, because cos minus theta is equal to cos theta. Pi minus 5 lies in second quadrant, so we'll get minus cos 5. So which is not the case for us, it is cos 5. So we won't be taking minus pi plus 5. And going to the next value, that is minus 2 pi plus 5. Minus 2 pi plus 5, we got minus 1.28, which is not the case. We don't have to do this because we have already crossed at 0. So there are no values here. Let's find this side. That is pi minus 5, that equals to 1.28. this and this not possible. So we were having 2 pi minus 5. 2 pi minus 5. So cos 2 pi minus theta is cos theta. So this is our answer. It is 2 pi minus 5. Okay. So B value is, let me write again here. So A value is this, B value is 2 pi minus 5. Now we have to find A square plus B square. So A square plus B square is equals to 25 plus 4 pi square minus 20 pi plus 4 pi square plus 25 minus 25. So 58 pi square minus 40 pi. 58 pi square. 8 pi square. So this is our answer. Let's go to the next question. Yeah, this is our final question also. So, yeah. Given tan A, tan B and tan C, and ABC lies in first quadrant. A value, B value, C value individually lies in first quadrant. So we have to find A plus B. Yeah. Let's take tan A plus B. This is tan A plus tan B by 1 minus tan A tan B, right? So given tan A value, tan B value and tan C value, so we'll go with the tan A plus B. Let's see at what we will arrive. So 1 by root x into root x square plus 1 root x by root x square plus x plus 1. Okay, by 1 minus, we have to multiply this and these get cancelled while multiplying, and we will be remained with root same value, so x square plus x plus 1. Okay, now we have to take LCM here and LCM here, so that will be 1 plus root x into root x by, okay, I'm taking by as here, root x square plus x plus 1 into root x by x square plus x plus 1 minus 1 by x square plus x plus 1. Okay. Here plus 1 minus 1 get cancelled and we can write this as 1 plus x. So I am using this place. 1 plus x by root x into root x square plus x plus 1 plus x plus 1 by x square plus x. So if we take x common, that will be x plus 1 by this value, x square plus x plus 1. So we can cancel this root times. Now we can cancel this also. We are left with 1 by, this is root x square plus x plus 1. So 1 by x root x into root x square plus x plus 1. This is what we are left with. Take x into the root. So we'll get x cube here. So everything will be under one root. We are writing everything under one root. Root of x square plus x plus 1 by x cube. That is x square by x cube is x power minus 1. This will be x power minus 2 and this will be x power minus 3 root. Root can be written as power 1 by 2. So x power minus 1, x power minus 2 plus x power minus 3 over 1 by 2. So this is same as C, tan C. Okay, so tan A plus B equal to tan C. That implies A plus B equals to C. And that is our answer. Okay. Okay, guys. Thank you.